Welcome back to my YouTube channel, Odavig Structure Hub. This is a place where you learn, build, and innovate. Today I want to tackle example number 3, and the question is from Kenya National Examination Council, that is module 2. So this is the question from retaining walls. The question is number 2, and it has part A and part B. So part A reads, illustrate using sketches 3 failures of retaining wall. That is 6 marks. And then part B, figure below shows a cross section of a concrete gravity retaining wall which retain a cohesionless soil of 2 different density whose angle of response is 29 degree. Determine the position of the resultant lateral thrust. Take density of soil 1 to be 2000 kg per meter cubic. Soil of density of soil 2 is equal to 2400 kg per meter cubic, and the question carries 14 marks. So this is the retaining wall, this is soil 1, and then soil 2. And then you have the depth of soil 1 is 2 meters and soil 2 is 3 meters. So let's begin with part A. So let's begin by part A, which is the 3 failures of retaining wall. So number 1, we have the sliding. And then number 2, overturning. And then number 3, bearing capacity. So these are the 3 common failures of retaining wall. So I will explain or illustrate using sketches. So we begin by number 1, which is sliding. So sliding occurs when the lateral pressure, which is PA, overwhelms the resisting force at the base. So the resisting force is the vertical, the summation of the vertical forces. So for here, it will be the force, the self weight of this retaining wall, and also the force as a result of the backfill. So if this horizontal force, which is PA, overwhelm the resisting force, then sliding will occur at the base. As you can see, this hole has been moved from the original place to here. So that is sliding. So we proceed to number 2, which is overturning. So number 2 is overturning. Overturning. So as you can see, this is the retaining wall. This is the original position of the retaining wall. But due to the effect of the overturning moment exceeding the resisting moment, this wall overturn in this direction, and it will overturn at point A, which is the toe of the retaining wall. So occur when the wall rotates about its toe. So it rotates at this point A, and overturning moment, which is given by PA times H over 3 exceeds the resisting moment. So the resisting moment is the moment due to vertical forces. So that is all about the overturning. I proceed to number 3, which is bearing capacity. So bearing capacity. So that is the bearing capacity. So it happened when the pressure exerted by the retaining wall exceeds safe bearing capacity of the soil, leading to the wall sinking. As you can see, this is the original position of the wall, but due to excessive pressure which exceeds the soil bearing capacity, this wall sinks. It sinks to this position. That is all about the failures of retaining wall, which was part A. I now proceed to part B. So part B of the question reads, figure below shows a cross section of a concrete gravity retaining wall which retains a cohesionless soil of two different density whose angle of response is 29 degree. Determine the position of the resultant lateral thrust. Take density of soil 1 to be 2000 kilogram per meter cubic and soil 2 to be 2400 kilogram per meter cubic. So the information, all the information is here. So let's see how we can tackle such a question. So for you to start tackling this question, you will first draw the pressure diagram as a result of the retained soil. So we will begin by soil 1. So for soil 1, we'll begin by the pressure of soil 1. So this will be the pressure of soil 1. So that is the pressure of soil 1. The intensity of this pressure at the bottom is given by K A unit weight of soil 1 times H1, and this will be the pressure, which is, let's call it force 1, and it will be acting at a distance of 2 over 3h from the top, or you can take it from the bottom. So let's take it from the top. If you take it from the bottom, you are supposed to take it from here. So for our case, let's take it from the top. So that is 2 over 3 H1. So this pressure will also cause another pressure on the second layer of the soil. Will also cause another pressure on the second layer of the soil. So this will be the second pressure as a result of this pressure, but it will be of the same intensity at the bottom. So this is K A unit weight of soil 1, H1, like that. So after drawing the pressure of soil 1, we proceed to pressure of soil 2. So the pressure for soil 2 before you proceed to pressure of soil 2, let's find where this force, the center of the force of pressure number 2. So we assume this pressure is acting at that point. So that is F2. So it will be acting at a distance of 2 plus H2 over 2. So 2 plus a half of this. We now proceed to the pressure diagram of soil number 2. So this is how it will look like. So this is the pressure diagram for soil number 2, and the intensity of the pressure at the base is given by K A unit weight of soil 2 over H2. So this is force 3. Then the center of the pressure from the top will be 2 plus plus 2 over 3 H3, like that. 2 plus 2 over 3 H3 from the top. After doing so, we now start solving the question. So you have been told to calculate the position of the resultant lateral thrust. So position of the resultant lateral thrust. So this one is given by this formula: F1 y bar 1 plus F2 y bar 2, this from the top, plus F3 y bar 3 over F1 plus F2 plus F3. So this distance is y bar 1, this one y bar 2, this one y bar 3, like that. So we now start calculating the forces, and before you can start calculating the forces, let's calculate the Rankins coefficient of active pressure, which is Ka. So Ka is given by 1 minus sine phi over 1 plus sine phi, which imply Ka is equal to 1 minus sine 29 degree over 1 plus 29 degree. Therefore, Ka is equal to 0.35, like that. So first one is the area of this triangle, which is a half base times height. So this is the base and this is the height, or WH square over 2 into bracket 1 minus sine phi over 1 plus sine phi, which imply F1 is equal to W is the unit weight of soil 1, which is 2000 times 9.81. You change it to gravitational, you change it to kilonewton per meter cubic. So you divide by 1000, then times 2 times 1 minus sine phi over 1 plus sine phi is 0.35, which is equal to, again, times h times h, which is 2 square times 0.35. So the answer is equal to 13.73. 13.73 kilonewton. We proceed to F2. F2 will be the area of this rectangle, which is length times width. And we have 3 times. The base is Ka, which is 0.35, times unit weight of soil 1, so that is 2000 times 9.81 over 1000 times H1, which is 2. So which imply F2 is equal to 41.20 kilonewton. We proceed to F3. So F3 is equal to the area of this, or you use WH square over 2 into bracket 1 minus sine phi or over 1 plus sine phi. So let's use this formula. So W will be the unit weight of the soil 2, which is 24 times 9.81 over 1000 times 2 times H is 3 square times Ka, which is 0.35, which imply F3 is equal to 74.16 kilo Newton. As you can see, we have F1, F2, F3, and also we can find F1, no, Y1, Y bar 1, which is 2 over 3 H1, then Y bar 2, which is 2 plus H2 over 2, and then Y bar 3, which is 2 plus 2 over 3 H3. So if to get, let's proceed to the position of the resultant lateral thrust. So allow me to clean here. Now let's calculate the position of the resultant lateral thrust. So this is the formula, and we already have F1, F2, F3, like that. And we also have Y bar 1, which is this distance from here to here, 2 over 3 H1. Y bar 2 is 2 plus H2 over 2. Y bar 3 is 2 plus 2 over 3 H3. So the position of the resultant lateral thrust, it will be Y top is equal to F1. Our F1 is 13.73 times Y bar 1 is 2 over 3 times H1, which is 2, plus F2 is 41.02 times Y bar 2 is 2 plus a half of 3, which is 1.5. 2 plus 1.5, 3.5, plus F3 is 74.16 times Y bar 3, 2 plus 2 over 3 times 3. So 3 will cancel with 3. So we will remain with 2 plus 2, which is 4. Then you divide by F1 plus F2 plus F3, you will get 129.09. So Y bar from top is equal to 3.6 meters, and Y bar from bottom is equal to 3 plus 2, that is 5, minus 3.6. So you will get 1.4 meters from the base, and that marks the end of that question. So if you have not subscribed to this channel, please subscribe and hit the notification bell so that you may be the first person to be notified when I upload a video. Thank you for your time. We meet again in my next session.